Wow, here we go again. Stream is up. Oh man, the allergies are setting in. Hay fever ting, bruv. So just while we get the stream started, just gonna munch on some Victoria sponge cake. Can't go wrong with a bit of Victoria sponge cake. So, as always, if you're watching this back after the stream has already concluded, then feel free to skip forward to the main content, which will be probably about 5 or 10 minutes once the stream has picked up a little bit. Wes, you were not first, I'm afraid, my guy. Michael was first. Michael was first. How's it going, Michael? Hello, hello. How's it going, everyone? Good to see you. Happy Sunday. How's your Sunday been so far? Exciting times. Which I'll tell you about in a minute. What's going on, Simewave02? How you doing, my friend? What's your vibe today, Simewave? You vibing in the live chat, or do you want to jump on voice for a bit? Hello, Orange. Haven't seen you here before. So this is the start of my stream. We're just kind of letting the stream pick up a little bit, but regularly, every week, probably about 3-4 times a week, I live stream my repairs. So I am an amplifier repair technician based over here in the UK, specializing predominantly in car audio and Class D, PWM, modern design architectures, and all sorts of stuff happens on these streams. All sorts of stuff. It's quite fun, loads of interaction with my live chat. I have multiple cameras, so we have this camera here with the live chat, got an overhead cam, got my Victoria sponge cake on it that I'm just finishing off before the stream starts, got my oscilloscope cam, which I'll just turn my scope on. We also have a camera on the bench power supply up here, which I need to slightly adjust. It always moves when I'm stopped streaming. So we have constant current on there as well. We also have a camera for the multimeter over here as well, so you can see the multimeter. And additionally, we have a camera that goes on my hat, which I haven't put on yet. It's a little bit uncomfortable, so I'll put it on later. But yeah, all sorts of cameras, and it's a good vibe. It's a good vibe for your Sunday, so stick around if you fancy. We also look at mains powered amplifiers as well every now and then, specifically Camco Vortex. I just repaired a Teak audio amplifier from the 1980s. Done a Pioneer last week as well from the 1980s. No, that was a 90s, that one. That was a 90s hi-fi unit. I've got a Lab Gruppen 14K that's on my rack to look at as well. Might get around to it this stream, we'll see. At the moment, for the stream that I've got planned for today, we're working on an old Earthquake amplifier. Got a JBL GTO41. I've got a STSON 2K by the looks of it, and also a Edge 1500. So a couple of Class D things lined up for today so far. So I apologise in advance, guys, if I sound a little bit sniffly. I do get hay fever, and it's that time of year. It's coming. Today's the first day that I can really feel it. So if I'm sniffing in a little bit, then I do apologise. Yeah, bear with me. What am I eating? Victoria sponge cake. Very nice. A little bit of cake before we start the stream. Always a good way to start off your afternoon with a bit of cake. All right. Cameron says, "Hi Sam, I don't know if you deal with this, but could you have a look at an old Technics Hi-Fi amp?" So I have repaired Technics Hi-Fi amps in the past. If you're based in the UK, then yeah, I could look at that for you. Depends on if it's worth it though. A lot of these Technics Hi-Fi amplifiers you can pick up for 40, 50, 60 pounds on Facebook Marketplace. My repair charges generally start at like 55, 60, so sometimes it's not worth it. But all right, cake has been repaired. Let's crack open this. Now this first one on the bench today is going to be Earthquake PH10000W1D. Look at this. You see this this marking here? So this is actually regulated pulse width modulated monoblock. So this is it says Class J, which is kind of just marketing. there isn't an official Class J as such. But what this does is it's very strange, and it threw me off the first time I repaired one of these. I was a little confused because, so you may have seen, if you watch my streams a lot of the time, or you repair things yourself, that power supply sections can be regulated. So when you are probing the low side drain of the power supply MOSFET, you won't necessarily always see a 50% duty cycle, nice clean square wave. If it's regulating, then you'll see what looks like a really strange waveform shape, a really messy waveform. And that is from the gate waveform going low duty cycle, and therefore regulating the rail voltage. This amplifier does that same thing, but it does that on the output section, which is very unusual to see. So the first time I saw that, I was like, something is not right here. But then I looked into it, because it seemed to be producing audio, and I was like, well, this is working fine, so why does it look so messed up? But actually, yes, that's how this works. So we're going to look at that today, and you can see exactly what that looks like. I can't speak today because hay fever. Dude, same! I'm glad I'm not the only one, so it must be a higher pollen count today. I'm dying. I'm dying up in here. Everything just feels like, whoa! So this is what the inside of the Class J 10K. It's not 10K. I think these are like 2500 watts RMS, something around that mark. We don't have any onboard fuses on these, that's fine. We can't use a fuse rating to kind of gauge what it should be power-wise. Now, has this been repaired before? Let's have a look. We have our power supply section here, a switch mode power supply consisting of a pair of SMPs that parallel after the rectifiers. Got one bank here, push-pull, one bank here, push-pull, so two separate transformers that then rectify, that then parallel at the rectifiers. The rectifiers in this board are all over here. As you can see, we've got 4 TO220 package rectifiers. We also have, are these voltage regulators here? No, I think these are drivers. Voltage regulators for auxiliary supply voltages, for like the preamp and stuff, are going to be, where are you? Here we go. Just about here by the looks of things. We've got some xenodiodes and transistors, so they'll be being used as voltage regulators. What else do we have? Got some large package components on here. Interesting. I wonder whether they're... actually, you know what? I think these might be the rectifiers, in fact. And these actually might be voltage regulators. Because these are labelled up as Q, which suggests that these are actually a transistor type of thing. Although usually voltage regulators are IC. Anyway, regardless of that, let's have a look and see why this is in the workshop with me today. I didn't get a note with this one to say what the problem with it was. It's not giving any signs of having a previous repair, to be honest. Oh my god. So let's have a quick read of the output MOSFETs, which are these ones. We have our output inductor. There's a tiny little thing over here, considering the amount of components. We've got 8 TO247 AC. No, more than 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 10 TO247 AC package output devices. Now, in a modern design, this would be enough to cater for about 12,000 watts RMS, like a genuine real 12,000 watts RMS continuous. But obviously, this is a very old amplifier, and so these parts won't be anywhere near rated high enough for that kind of power. I suspect we're looking at about 2,000 watts here. Wait, oh no, hang on. Just looks like we might have some rail voltage still in the board there. My meter is not happy about that. Let's just clamp a ground probe onto here and have a look with the oscilloscope to see if, usually amplifiers will have pull down resistors on the rail capacitors, so that after a few minutes of powering down there's no voltage left inside. But let's have a look and see what we've got on the scope. So that was over here somewhere. Whoa! What have we got? What have we got? We still got 22 volts positive in there. Do we have any negative rail? Okay, no negative rail that I can see here. So we still got 22 volts positive rail. Excuse me, just sneezing there with the hay fever's catching up on me still. My gosh, I need to go and grab a handkerchief or something. How's it going, my friend here? I can't pronounce your name because I don't know what those characters are phonetically, but how's it going? Good to see you here on the stream. The one I played uses the HIP 4080 for audio driver. I played with one that was I played one of that. Only thing mine was American handcrafted Earthquake. So the 4080 is a Howard Acoustics, my man Henry. How's it going, bro? Good Sunday. Happy Sunday to you, my friend. How's it going? Good to see you. Look at this old thing. Look at this old Earthquake, bro. This is some bad boy thing. This was pretty. This supposedly Class J, which is a bit of marketing stuff. Doesn't really exist. It's Class D, and it's PWM controlled on the output section, which is really unusual. Never ever see that really. Yeah, for the HIP 4080 is just a Class D full bridge drive package. So yeah, I don't think that you can use the 4080 for pulse modulation, like kind of like duty cycle modulation or regulation of the output section with that. Never seen that used for that purpose myself though. Anyway, so okay, so we still have 22 volts in here. Let's just be careful with that. But that's cool. That suggests that obviously there's no dead short on any of the rails or anything, because there's still 22 volts with a positive rail in here. So looks like we have positive rail all over on this side. Here we go. It's these 5. 1, 2, 3, 4, 5. These are the high side FETs, and we have 1, 2, 3, 4, 5 low sides. All right. So no dead outputs. So I doubt we've got dead power supply FETs, because if we did, they'd be like cooked up a little bit. Yep, that's fine. That's just charging the cap backwards. So let's just put some power to this then and see what the issue is. I didn't get a note with this one to say what the customer was having an issue with. So we're just gonna have to power it up and see what it does. I'm going to go with 10 volts in and turn my signal generator on, plug in some RCA signal, and see what the jam is. If it had no audio output, it could just be that the switches on the side here were a little bit bad. Let's see if I've got this customer saved on my phone to see what he was saying about it. Earthquake. Wah 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 wah. Okay, nothing there. Let's have a quick look in Facebook messages. Search for earthquake. Messages. Nope, not that one. Not that one. All right, here we go. Ah, yes, found him. Right, let's have a look. What was the issue then that that he was quoting this amplifier had? I was wondering if you better look at my amplifier. I messaged you about a month ago for repair. What was the issue with it though? Here we go. I have no sound playing from it. I checked all the usual culprits, RCA connections, blah blah blah. Okay, so power's up but no sound. Right, let's confirm whether that's the case then. We've got RCA signal going in. Got 50 hertz on the signal generator here. Make sure the gain is turned down a little bit. Bass boost is minimum, level is minimum, high pass filter is minimum, subsonic, let's fix that off. Phase shift 0. Okay, let's go and see what we're dealing with. Probe the power supply MOSFET drain first. And we should have some pulses coming in here. There we go. Okay, so the power supply is backwards as well. Excellent. So the way the power supply is working on this one is that we have our 12 volts from the battery, or it's actually about 10 volts there coming from the battery on the middle leg, which is usually where you have the PWM, but we actually have that on leg 1 and 3, as you can see here. So this is working, the power supply setup in the same orientation as the MTX Thunder amplifiers. They're also the same as this, where you have the 12 volts on the drain, and then you have this kind of waveform on gate and source. Right, cool. Let's check the output section. So as we know, we've got, there we go. we've got the low side over here, and we have nice looking switching there, as you can see, and it's actually modulating with my input sine wave. So we know the amplifier is working. Look at that. I'm turning the signal generator up, and that's actually working fine. So why does my friend here not have any output? Let's have a look on the speaker terminals. We could have, this inductor, for example, could have snapped from the board. So let's just check the speaker terminals to see what we've got. Okay, looks like we do in fact have a sine wave. Okay, so this could be a no fault found. Well, at least you got to see the amplifier. Let's just wiggle the inductor to make sure it's not intermittent. No, it looks good. Okay. One last thing that could be meaning that we have no output on a speaker, even though we see a sine wave, is if this speaker negative terminal, if that doesn't have a connection back to the rest of the circuit, then that could actually be causing there to be no output across these terminals when you have a speaker connected. So let me just connect up a speaker. And let's see. Hey Sam, do you have any experience with RE Audio XXX subwoofers? Yes, actually, a little bit. I owned a pair of XXX V3s, the XBL 2 motors, pretty nice. And I also owned or worked on a XXX V4. I did a recone on the XXX V4. So I wouldn't say I've had experience in, like, installing them, not the V4s at least. But yeah, I've used them a little bit. Why? What do you want to know? Man, the terminal screws on this are like up in the sky. I'll show you this in a moment. Let's just get this little sub connected here. RTS, how's it going? Happy Sunday, bro. I wonder if we see full digital out amps in high power application. Full digital out amps in high power application. How do you mean? Those earthquakes were extremely expensive and extremely anemic and underwhelming. Interesting. No wonder they're expensive, because they're all like very bespoke, like bespoke circuit design, bespoke heatsink, everything. Like, yeah, no wonder they were expensive. I'm reversing a many hours long video with an unstable Phenom 2 computer with 4 GB RAM. It's underclocked to 1 GHz and 400 MHz RAM. Pretty fun. Reversing a many hours long video. I don't know what you mean by that, but it sounds interesting regardless. Do you mean a Pentium 2 or a Phenom 2? I'm not familiar with Phenom. Henry, have you done anything with your I think you've got some little XBL2 mids. They're pretty cool looking things, hey? They make a really cool project. Let me know if you've done anything with those yet. I'm not sure what I would do with them. Like, would you have them for hi-fi? Would you have them installed in a vehicle? Would you ask them to play up the range, or would you just give them kick bass, mid bass duties? Wes says, side chat about glass Zener diodes. I have to replace on the outputs, but they are rated in volts. How do I identify volts of a dead Zener? If the Zener diode is dead and it doesn't have any markings on it, then you're a little bit stuffed, unless you can find somewhere else in the circuit, like either in another identical section of the circuit that has a working one of those Zener diodes. Okay, so what you want to do is you want to look at the circuit, see, right, is this circuit repeated anywhere else, or is there anywhere else in the circuit that looks like it uses the exact same Zener diode? If it does, then pull a working one, and then you can hook up a test circuit to identify what voltage the Zener diode is. It's just a power supply with a high value resistor and you just keep increasing the voltage, and you just look with your scope or your multimeter as to where the Zener is clamping the voltage to ground at. It will start clamping it to ground, and it will hold it steady at that voltage. So yeah, look for an undamaged one of those Zeners in the circuit somewhere. If you can't find one undamaged, then you might just be looking for a schematic at that point. Or you could reverse, sort of like look at the circuit and be like, right, what is this Zener diode supposed to be doing in the circuit? What is its function here? And therefore, what voltage would make sense in this circuit here? If it's being used as a voltage regulator, have a look at the components that the voltage regulator is supplying and what kind of voltage they need for their supply. Or if it's clamping a drive wave to a specific limit, then look at what the sort of voltages from the drive circuit are going to be to see where you want to clamp it off at. Yeah, there's ways of figuring it out. Okay, so let's just power this up and see, because I'm getting a clean sine wave on the speaker terminals, so I don't know if this actually has a problem. 27 hertz, power up. Okay. Yeah, that's working fine. So we have a no fault found. Excellent. Always happens on the stream, but I'm not actually too sad about that, because I'm trying to get through these as quick as possible, and I wasn't really looking forward to doing a big long repair on these, because they're like a strange, unusual circuit design, and they're pretty old now. So I'm quite glad that just works. That'll just be an inspection and test fee, that one. Now we could bench test it to see what power it actually makes, but doing so is pretty stressful for amplifiers, so I wouldn't want to kill it and then have to repair it. Mark Hatcher, good to see you. Good to see you too, my friend. How's your Sunday going? As far as I understand, Class J is basically Class AB with dynamically regulated rail voltage to kind of get the best of both worlds. No, that's you're describing Class H. This thing here is just Class D, and the Class J markings are just marketing nonsense. What was the fault on this one? No fault found. Customer claims that it had no output. But I'm getting beautiful clean output, so. Compared to Class D, you'll have another transistor stage after the output filter inductor. Yeah, so in this one, there's not. It's literally output MOSFETs through inductor through to speaker terminals. So the Class J markings are just marketing. Well Sam. How would you recommend connecting 6 dual 1 ohm 15-inch subs on 3 amplifiers? Hang on a minute. What I would do is, so you got 6 dual 1s, so you've got 12 1 ohm voice coils. Okay, so there's no real clever way of doing that. What amplifiers are you planning to use, Frank? That will change things a little bit. Hello, Sergio. How's it going, my friend? 3 amplifiers. So either way, it's going to be like 2 subs per amp. Dual 1. So each amp will be able to be wired to 1 ohm, which would be nice. Most amplifiers are 1 ohm stable. Going to sneeze again now. Excuse me. Do you have a personal car setup, and what is it? Yeah, so I've got a demo van, a Mercedes Vito, which has a 6th order wall with two 15s. I've got a pair of Digital Designs Z415s, full carbon, and I've got a Tarap's HD10K at 0.5 ohms, 4 AGM batteries, stock alternator. It's doing 155s at 25 hertz. And I've got a Proton Gen 2, which has just a nice SQ setup in it. I've got Digital Designs A series mids, tweeters, AT28 tweeters, AW3 mids, and AW6.5s in 53 hertz transmission line enclosures on the door cards. All run on a special edition Genesis 8-channel amplifier in the back, which is high bias class AB. No DSP, just Alpine 9855R with time alignment and EQ and crossovers on that, which is more than ample because of my build. All the positioning, the positions of all the drivers are good, so there's minimal corrections needed. So the flexibility of the head unit is actually more than enough to get a really nice sounding setup in there. Subwoofer wise, I haven't got a sub in there just now. I usually just run whatever random crap I've got laying around, but I do want to go true infinite baffle in that with a 24-inch if I can. Best placed to contact you for an amp repair. I'm the guy who sent the crown in as a donor for Donnell. Oh, yo, Cameron, how's it going, my friend? I still have that here, actually. I need to do the transformer rewind on it. Yeah, just Facebook, bro. Or just message Donnell for my number. He'll give you my number. I give you permission, Donnell, to give this guy my number. So, yeah, just shoot me a message on WhatsApp. WhatsApp's best way. We can get you sorted. Robert says, I'm still topped out 138 dB on my warm-up setup. I've only got a couple more tricks up my sleeve for the 140 dB single sub warm-up setup. When in doubt, if you're looking for numbers, just go up in frequency. If you don't care about doing it at a specific frequency, go for a smaller car and tune everything to cabin resonance frequency. I'd go for the Helmholtz frequency, the Helmholtz resonance. So have passenger door open, driver's door closed, sensor on the driver's headrest or driver's windscreen, depending on how you're doing it, but sensor in the sealed side. Calculate if you can the Helmholtz mode of that cabin with the passenger door all the way open. It will probably be somewhere between, usually depending on the car size, could be somewhere between 28 and 35 hertz. So you could play one of those frequencies. If you're wanting to do this with no doors or windows open, just completely sealed, then you want to just work out the quarter wave resonant of the cabin, which will be a lot higher, maybe like in the 40s, maybe the 50s, sometimes in the 70s if it's a small car. So you want to tune and play those higher frequencies. And yeah, 140 dB is very achievable these days with very cheap stuff. Next on the bench, we have a JBL GTO41, and this has a note on the back which has some personal information. So I'm just going to remove that. Have a look. This one says, we spoke by WhatsApp. Was working okay, then started to smoke. Okay, so we definitely have a fault with this one. Bro, the hay fever is killing me today still. Alright, so smoke from an amplifier like this means power supply section failure, possibly caused by an output section failure. So this could be a full rebuild. Let's have a look. These also can kill the rail capacitors. So we could have smoke coming from the rail capacitors instead of MOSFETs. Let's have a look. Let's get it open and check inside. Oh my god, I'm dying. Nah, I'm not sick, I've just got hay fever. Allergies to pollen, bro. I went for a walk in the forest this morning. That was a bad idea. I might have to go and get some tissues though or something. Right, back in. We're sorted. We have supplies. Do you know where I can get output terminals for JBL amps? Donor boards, I'm afraid, is the only way you're going to get replacement parts for these. Alright, these rail capacitors have a tendency to fail. When they do, they bulge out. These are lovely and flat. Those are perfect. Power supply ones also, if the amp's not used in a while, they can fail when you first power it up again after a long time of being stored, but they are also just fine. Looks like we have some evidence of smoke over here by the power supply MOSFET, so that's as suspected. Yeah, you can probably get terminals that are compatible from China. I haven't looked, to be honest, because I've always happened to have donor board available. Yeah, all the power supply FETs here are cooked IRF 3205s. These are toasted, so let's get these out. Now, I'm curious, do we have dead output FETs which cause these power supply ones to fail? Let's have a look. Okay, this is a full bridge amp, so we've got 2 sets of high side and 2 sets of low side. Good so far. Ah, rare. Very interesting. Okay. No dead outputs. So something will have caused the power supply to overload. So we might have a shorted transformer. So we need to remember this and bear this in mind. Because if we just replace all the power supply FETs and don't check for a reason why they failed, then it may just fail again because we haven't actually fixed the initial problem. So let's get this thing out of the heatsink and let's repair the power supply, and we can go hunting for what caused it to fail like that. Interestingly, it's only these 4 which have gone bad. It could be vibration damage actually. If one of these MOSFETs has a snapped leg, then that would have killed just this bank and not the rest of them. Okay, no, none of these seem snapped. Interesting. Very interesting. Something will have caused those to fail. So, exciting news. So, in response to Sergio, you need some wine to fix that. So, I could have some wine, but I can't because this evening I'm going on a drive. I'm driving this evening. I'm going to go and pick up the vehicle for Boomer Bust Season 2. So I'm well excited about that. So on a little drive this evening, and we are picking up the PT Cruiser test vehicle that's going to be used, hopefully, provided it is as described and it works in with how I've got planned. It'll be used for Boomer Bust Season 2. So that is very exciting stuff. And that will actually allow me to start making preparations and working on that a bit, and yeah, getting things sorted for the start of Season 2. I was thinking it would be fun to go live, on the journey, but in order for that to be safe and responsible, I would need a passenger to deal with the live stream and just read out live chat and stuff while I'm driving, so I can just respond vocally to stuff. Because I don't want to be looking at a device or anything like that. Very responsible while you're driving. So. No, so yeah, it's a model car. It's a 1/6 scale RC car. An American company, New Bright, used to make back in the 2000s massive 1/6 scale remote control cars. 1/6 scale is freaking gigantic, absolutely massive, which is actually the perfect scaling for boom or bust. Boom or bust is a 1/6 scale, so that's going to be really good fun. SK Audio, I am fine, I'm not unwell, I just have hay fever, so I am allergic to the world. I'm allergic to outside at the moment, at this time of year, unfortunately. Are you going to try one of those mini subs in that RC car? So, Kyo, it doesn't sound like you've heard of Boom or Bust. So, what was it? A couple of years ago, I made a video series on my channel called Boom or Bust. I recommend you check it out. It's very interesting and pretty entertaining, I think. I had a lot of fun doing it, and people said they liked it. So just go on my channel once this stream is finished, or when you're next free, and just search Bearvid's Boom or Bust and have a watch through those episodes. They're freaking great. And season 2 is going to be even way better with what I have planned. The only thing that's slightly annoying about Boom or Bust is just the people that didn't understand what it was, they didn't grasp what I was doing. The only way that you can understand what I was doing is if you watch like the pilot episode or the first episode where I explained everything. But when Boom or Bust was like in action, say you kind of tuned in for your first episode on like the 4th or 5th one, then it might not make a lot of sense. You're like, well, what's this guy doing? Why is he playing 150 hertz? And like, yeah, a lot of people didn't quite understand what I was doing and what it was. But I don't know if there's a way for me to really kind of do it so that every episode, if that was your first one, then you can understand what was going on. But what I will say is for season 2 of Boom or Bust, I think that will be less of an issue. The way that I have plans for season 2, I think that if you just randomly came in and started watching it from like like episode 5 or something, then I think it wouldn't necessarily need to make sense. All right, let's get these dead 3205s off, and then we can start loading up some new ones, checking the drive circuit, and figuring out why they all failed. So yeah, none of the output MOSFETs died or anything like that, so it doesn't look like there was an overcurrent event that killed these on the output side. I suspect one of the power supply transformers is got a bit of a shorted wind, which is a shame, because that can be a bit of a pain in the butt to sort out. B2 sub, B2 audio, do a nice mini sub. That'll be awesome in an RC car. Have you seen my video on that? It's my most viewed video in years. If you haven't seen that, go check out the video I made on the B2 2-inch subwoofer. And you'll also understand, if you watch that video, why that can't be used for Boom or Bust. and why it actually sucks as a driver for doing anything useful with. Yo, sine wave, dude. Fuel money on me, dude. Appreciate the 50, man. That's insane. That's a massive amount of money. Thank you very much, dude. You're far too generous, dude. You need to start saving some stuff for yourself, bro. Thank you so much, bro. That's massive. But you don't have to do that. It's cool. But thank you very much, man. I appreciate you. That's crazy. Big money. Thank you very much, man. And I say this because I know you've dropped bare donations in recent streams, so thank you very much. I really appreciate it. But also, just make sure you're looking after yourself as well, bro. Alright, well, SK Audio, right now, while I'm desoldering these parts, go and watch my video on the B2 Audio mini sub. Okay, go watch it right now. Let me know your thoughts about the sub and why or why not we can use it for various different things. I recommend it. It's a really cool video. You won't miss much. I'm just desoldering and soldering in at the moment. Live stream for the drive boom or bust. Yeah, like I was saying, I would love to do that, but I would need someone else. I'd need a passenger to manage the live stream and to read out live chats and stuff. I wouldn't be able to live stream, read the chats, and focus all my attention on driving at the same time. So I need someone to come with me to do that. I can't think of. There's no one locally at the moment that would be free this evening. I've got a really good friend who's local, but he's not around this weekend. So. Sine wave is not local. Sine wave is a 5-hour drive away in one direction, 10-hour round trip. So there's no chance of that, unfortunately. Unless Sine wave went live with me, and you read out all the live chats from your place on Discord, like how we've done the last few streams. That could work. Probably only do it one way though. Not sure what time would be best. I'm probably leaving here around 6:30 p.m. and then it's about an hour and a half away. So I'm coming back, probably getting back like do live stream on the way back from like 8 till 10 or something like that. That's UK time, so you have to adjust that for wherever you live. Oh yeah, the main cam has frozen, hasn't it? Yeah, I'll just quickly sort that out. There we go. Alright then, so all the FETs out, we can check the drive circuit. So there's only really, there's two reasons, or two and a half, three reasons maybe, but two main reasons why the power supply MOSFETs may have failed in here. First reason is something on the output section of the amplifier shorted and tried to draw excessive current through the power supply FETs, and that's why they failed. We have no dead output FETs, so it's unlikely to be anything on the output section that drew excessive current. The transformers may have a shorted wind, which would count as an output side short, so that could be the case. The only other reason, if there's no shorted transformers, no shorted output FETs or anything like that, the only other reason why these FETs might have died is if the drive circuit driving them failed, which is kind of unusual to happen, but TL494s can fail and go rogue and do weird stuff, so that could be a reason as well. The third reason, which would be extremely unlikely, is if one of the MOSFETs just randomly failed being used within spec, but you rarely ever see that. Alright, cool. No shorts, no solder bridges. So let's just put some power wires in here and have a look at the drive waves. The gate resistors on this thing are 100 ohms, which is kind of crazy high. It's to prevent there being too much EMI from the power supply. It causes the FETs to switch a bit softer, which reduces the EMI. So that's why they're so high. We can reduce them if needed, but if I'm just going to be putting 3205s or similar FETs back in, then there's no need to really there. It's not putting 100 ohm gates isn't going to drastically affect their operation or their ability to pass current. They're just switching a little bit softer. Maybe I had a bad connection on the power terminals. Yeah, maybe, but it wouldn't really cause the output FETs to fail like that. Sorry, it wouldn't cause the power supply FETs to fail like that. Yeah, so Cameron, obviously I can't share my number here, but just message Sinewave02, get him to send you my number. Alright, fantastic. So let's check the PWM on the gate pads. So power on, we have 12 volts going in, and we're looking for little PWM pulses on the scope. We're going to probe this gate leg first. Excuse me, I've sneezed like about 37 times so far this live stream. Lovely. Alright, what do we have? We have beautiful. Muy bien, very nice. That's on bank A, and on bank B, it's looking good as well. This side that failed, we've got 42% duty cycle it tops out at. It could be a bit higher, but that's fine. Let's just connect the other channel to make sure that this is working in push-pull. Yep, looks good. Sorry, I forgot to unmute it after sneezing. I think I've sneezed about 37 times on the stream so far. But yeah, there's no The drive circuit's perfect fine. There's no problem with the drive circuit. So likely is we've got a dead output transformer, wind, shorting or something like that. Or it's just a random failure of the power supply FETs, which is very unusual. But yeah, let's just see what's going on. New power supply FETs loading up. Yeah, plenty of dead time on this power supply. Obviously, the gate resistors are 100 ohms, so you couldn't really go too close with the dead time because the MOSFETs aren't going to switch on and off particularly quickly with that high of a gate resistor. There's no parallel diode or anything like that either, so. Now, if I sneeze with the mic unmuted, it'll be RIP headphone users. People will be suing me for a new pair of headphones. All right. I do love these amps, man. These are wicked. These things are sick. You know what I wish? I wish JBL would make a current modern 10K. How sick would that be? Or Alpine even. Bro, imagine Alpine made a 10K modern amplifier. That would be absolutely awesome. I think the biggest amplifier that Alpine ever made was about 2500 watts. Oh, man, come on, you can do better than that. Just put all this Chinese sound digital clone nonsense to shame. Design us something freaking awesome. Alright, sweet. They are all soldered from the bottom. Let's just have a confirm that they would have some good solder connections from the top as well, especially on the ground trace. Because the ground pad is actually on the top. So I want to make sure the solder flowed through nicely to the top on all of these. There we go. Yeah, that's looking good. Alright. So this should come on and play now, if there's no other issues, but I suspect there is something wrong because they died in the first place. So let's go for 9 volts. Don't want to stick it with a 12 just yet. 3.7 amps, just letting minimum voltage in to start with, and let's probe these 4 FETs, which are the ones that failed, and let's have a look at what the drain waveform looks like. Let's get the remote wire connected. Alright, so no excessive current draw there yet. We have class D output switching as well. Now let's wiggle around the transformers. Nani? This is fine. What? Random MOSFET failure, hey? That is crazy. Okay. There's one other reason but I can think that those power supply MOSFETs may have failed, right? There's definitely no vibration damage. So the power supply FETs just died by them freaking selves. And these amplifiers, these 14001s, the bottleneck, the weakest link in the chain in terms of current handling across the board is the power supply FETs, okay? So the output FETs in these are absolutely stout. I mean, you've got enough output FETs here for about 5k, straight up. The output section is very overbuilt. But the power supply side, 8 power supply FETs. If they were 1404s, be right. But 3205s with the high value gates, they are the weakest link in the chain. So it's possible that whoever was using, the customer was using this amplifier, was clipping the crap out of it and just demanding huge amounts of current more than what it was designed for. And so the thing that was the weakest link in the chain, being the power supply FETs, they just failed. So I have actually finished some small upgrades. These parts are slightly better than 3205s. But let's have a quick look at the gate waveform. I just want to make sure that with these new parts, the gate waveform looks okay. It's not too slopey. Oh no, that looks beautiful. So nice and easy to drive, modern parts. Oh yeah, look at that gate waveform with 100 ohm gates. That's not too bad. We've got more than enough dead time to account for this slopey off. We only got 42% duty cycle there, so yeah, that's beautiful. Perfect, no issues there. Nice. Completed. Oh my god, my face is on fire. No, so the Brazilian stuff is fine. The reason that it's Chinese nonsense is because they haven't done a good job. It's not a direct one-for-one clone. They've taken the circuit and like there's loads of poor optimization, loads of poor circuit choices. Like the Brazilian original stuff is like okay. It's not amazing, but it's fine. But the Chinese clones of it are absolutely awful. Yeah, man, hay fever allergies coming in strong today. Alright, let's get this back in the heatsink and then let's move on to amp number 3. We're getting through some stuff today, guys. If we're lucky, we might end up looking at the Gruppen 14K. That would be pretty cool. Yo, someone say straight up. How's it going, my man? Good to see you here, bro. Hope your weekend's going well so far. A bit of glue in that one, I think. It wants to fall off. It's like streamers all over again. Yeah, it's been stream after stream, hasn't it, recently? It's been nice. Been enjoying it. Rather than streamers, what is it? It's like springtime, isn't it? Streamster. Easter? What else isn't in the springtime? Easter, Pancake Day, Mother's Day. A bit more thermal paste on these. Why not while we're here? Fresh thermal paste on all the power supplies we've just fitted. I'm realizing I'm like 10 minutes off the live. Oh, yeah. If you watch the live, oh, by the way, any of you guys right now can do this. Set your playback speed to ×2, and then you'll catch up with the actual live. Even if it says that you're currently watching me live, play back the stream at ×2 speed, and you'll actually fast forward a bit to the live. Right, that's 46 sneezes so far today. Afternoon 13 BTR, yo, how's it going, my friend? Suffering with the allergies today, dude. Up in the Bear's workshop. It's too fast. For you, I'm watching at 1.5 times. Oh yeah, so I do speak quite quickly compared to other YouTubers. So most people on YouTube, when I watch YouTube content, I'll watch it in times two, um, just because I can absorb the information still, and I get through more content at times two rather than watching it at slow ass speed. So some people speak really slowly and they just take a long time to get to the point. I think I probably speak a little faster than a lot of other people. I'll tell you what I do, what I've noticed is my speech, I will speak slower in parts where I feel like I want to be understood with what I'm saying. So like just then, for example, I will speak slower when I am wanting to be understood well. However, if I am saying a sentence that doesn't really matter, or that's just kind of joining two sentences together, or joining informational pieces of information together, or adding extra context, then my speech rate drastically speeds up. So although I speak pretty fast, I would say, going by regular standards, a lot of people still say that I'm easy to understand. And I think that's just because the bits that are critical to understand and the bits that are critical to hear and the critical for you to understand what I'm saying are I generally tend to slow down for and put emphasis on, and then other bits that aren't necessarily so important I'll just whisk through. Having hay fever and then having to look down is the worst thing. Yeah. Oh yeah. Oh no. Why does that hurt? Oh my god, that's awful. Oh yeah, like you're putting your eyeballs down is not nice. You talk fast as frick. Yeah. Pollen. Yeah, pollen. Tell us what that modern 10K amp would consist of. Oh, good question, man. Alpine. With Alpine, it could be anything. The problem is with Alpine amps, yeah, it's like, it's even their smaller stuff, the PDX stuff. There's so much going on that amp that I have no idea what it's there for, what it's doing. Like, it looks more like a computer motherboard. Obviously, I know what a lot of the circuit is doing and what it's there for, but a lot of like, Alpine amplifiers seem to have a lot of like sort of logic or control circuitry and stuff that I don't ever see in any other amplifier. And it never fails, so I never need to like look up the chip numbers, figure out what it's doing, blah blah blah. Like none of that stuff ever fails. But you look at the PCB of an Alpine amplifier, modern one, and it just looks absolutely complex as heck. So yeah, I suspect it would have loads of monitoring. I suspect the projection circuit would be incredible. I suspect it would have barely any barely any like cross conduction, switching losses, EMI. It would just be pretty badass, I think. I think it would probably sound. I think it would probably measure great as well. I think if you put it on a THD meter and you did all the measurements of how good it technically sounds, I bet it would be amazing as well. Oh my life! The sneezes, bro! Right, how are we looking? Just going to do a quick test with this with a speaker connected to confirm that it's happy playing into a sub as well. Oh no, I think we're on like 55 now. One, two, three, four. Fourth one over here. Right, let's have a look at the controls. Where were the gain and the bass boost positions, etc.? Let's have a look. We have input level. What? Bro! Okay, so yes, I suspect this was being absolutely clipped to death, and the power supply FETs were the weakest link in the chain, which they are on these, and that's why it failed. Dude! What the fuck? At least the low pass was down low. these terminals are a bit buggered. Right, a bit of RCAs. Alright, a quick video for the client. There we are, buddy, all sorted. It's 12 volts going in, and crank that up. Nice clean sine wave, playing really nicely. This has got up to 14 volts as well. There we go. Video to send to the customer, and that's that one off the bench. Now we can move on to amp number 3. So amp number 3 is going to be this little thing, STSON EX3000 EQ. What's inside and what's wrong with this? Too big, too small, but it's fine. Alright, so we have a power supply transformer, very wobbly. That's going to kill itself at some point with vibration. Looks like this has been apart before because it's got a missing screw on the main board. Zoom in for you a little bit here. Output inductor. Looks like it has had some glue used on it at some point. Some third-party repair glue. No burned power supply FETs. Check output for short. Okay, no, oh wait, okay, output side short. We have one, well, at least one dead FET here on the output side. And what are you? You're IRFB 4127. Okay, nice. Are you all the same batch? Yep, all the same batch. Is your neighbor dead? Yep, neighbor's dead as well. The drive circuit for these is IRS 20957. So yeah, the same kind of setup as all the Sound Digitals and the Chinese clones that are coming out. Very similar setup, very similar amplifier, just with the STSON logo. Yeah, it's one of them days. Can I pass 100? Yeah, probably. I think I've definitely sneezed. Probably. I wasn't counting at the start, but it's got to be. It's got to be getting on for 60, 70. 60 or 70 sneezes so far today. Very nice. Bearvid's sneeze stream. You heard it here first. How does that work with only one rail cap? So it uses a single positive rail voltage. And the output sine wave then oscillates from a floating midpoint up to positive rail and down to 0 volts or ground. IRF B4127. Do I have some of those going spare? Let's have a look. Surprised this uses 4127s to be fair. This could definitely get away with 4115s. That would probably be better in here. So it has a floating ground point between them. Yeah, it's the way that the output circuit and the drive circuit is set up is that it creates a arbitrary sort of floating midpoint, which is just based on the duty cycle of the output section. So if you think about it, if you think about how Class D works, okay, if you've got a pulse of positive rail and then a pulse of negative rail, okay, if they're both 50% of the time each, then the resulting voltage of a small pulse of positive rail and a small pulse of negative rail ends up being dead in the middle of them, and usually that's 0 volts, right? If you've got a regular amplifier with a positive and a negative rail, if you've got a 50% pulse of 100 volts and a 50% pulse of negative 100 volts, then at the output inductor, that then just then those two pulses, they even out to be zero. Whereas if you only have positive rail, so from 0 to 200, yeah, then a 50% pulse of 200 volts and a 50% pulse at 0 volts averages out at the inductor to be 100 volts, dead in the middle. And there's actually a side effect of using IRS 2092s in amplifiers with a single positive rail voltage. Because of how the 2092 is set up internally, the rail voltage, the amount of rail voltage directly impacts and directly changes the duty cycle, the idling duty cycle of the output section, the self oscillation. So you have to kind of calibrate a point that's a kind of perfect point that you want the amplifier to make its power at with a car amplifier, whether it's 12 volts or 14 volts. Because if you increase the power supply voltage, say from 12 volts to 14 volts, then the rail voltage will then increase as well. And that rail voltage increase will lower the duty cycle on the PWM, on the Class D switching, which will mean that the power gains going from 12 volts to 14 volts will be quite minimal, because because the duty cycle is now no longer at 50%, it's now maybe at like 40%, you're going to clip the top or the bottom of the sine wave earlier than needed, because the floating midpoint isn't in the middle anymore. It's like slightly closer to one of the rails than it should be. And that's the side effect of using the 2092 in a single rail voltage Class D amplifier like this. So the 20957S is a far better choice when you're doing this kind of repair. Sorry, this kind of design. How do you get a floating ground without the second output? No, so it uses the duty cycle of the output section. I'll show you in a minute when we power it up. Depending on what type of amplifier design this is, I can't remember if STSON have designed have put in sort of like the floating midpoint to build and rise before Class D switching initializes. But as soon as Class D switching initializes, you'll see that it locks into pretty much dead on half rail due to there being 50% duty cycle at idle on the Class D switching. Yeah, so there aren't any Korean amplifiers that use a single positive rail voltage like this at the moment. There's nothing wrong with it. I don't mind it. I think it's pretty cool. Makes no difference to the end user or the output of the amplifier or anything. Yeah, I have no problem with it at all from a design standpoint. Alright, so there's a couple of replacement MOSFETs fitted in there. We don't know if the drive circuit survived, so let's just have a look with a multimeter and get some multimeter readings, which will tell us a little bit about the drive circuit before we power it up. So this side was the unfailed side, so let's just put our meter. So we got 562, 576, 575, 560. Yeah, well, that's looking about right. Let's flip the probes. Got 829, 829, 16, 16. Yeah, it's looking literally identical, so that's promising. Gate resistors are 1 ohm. 1 ohm gates. You'll love to see it. And that's just a cop out, that is. Having 1 ohm gate resistors is just a cop out. But whatever. They're fine as well. So that should probably just come on and play now. Cost reduction? Yeah, maybe. I'm amazed at the Taramps DS2000.4. It had points on the PCB for a fan, but no fan was installed, and all the other output inductors had completely loose windings. Transformer also used few thick winds. Interesting. Right, start off with 9 volts, just keep things safe. 5 amps going in. Let's power up and see what we've got. So that's our high side, 70 volts. Oh. Okay. We just have positive rail on all of these, which doesn't quite seem right. Unless this is work. Ah, wait, is this one of the interesting ones that works in a different way? Hang on a minute. Ah, there we go. Alright, so we've got low side and low side there. Yeah, that's working perfectly. So on the speaker terminals, actually on this one, on this one for some reason, and this is the STSON way of doing it. So on the speaker terminals, we rise all the way up to positive rail, and then when Class D switching initializes, we jump down to half rail. So you can see there we've got about 50 volts DC on, it's just a little bit less than 50 volts. It just looks like 50 because we've got the bit of noise there coming through the inductor. So it's actually a little bit less than 50 volts DC. We're like 40 something there. But yeah, it's about, actually no, it is pretty much dead on 50. 20, 40, 20, 40, 60, yeah. 50 volts DC, and the current rail voltage is pretty much exactly 100, yeah, 100. So it's exactly half rail. There you go, there's our rail voltage at 100, and our half rail with a bit of noise on the output side from the inductor at 50. Then when we remove the remote, the speaker terminal jumps up to rail and then back down. Just watched it. Excellent video on the B2 sub. Shame it's not suitable for lows. Yeah, exactly. So it's not designed for any real-world application use. It's just a novelty item. It's pretty cool though, for what it is. But yeah, it's just for fun, just to mess around with. Nothing too serious. Sorry, excuse me. Can you probe that power supply switching node to see if the 1 ohm gate resistor is fine? Do you mean the 1 ohm gate resistor on the output FET? So the 1 ohm gate resistor being used here, the 1 ohm gate resistor being used here is just to get around the fact that there's going to be some cross conduction due to not quite enough dead time and poor circuit designs to get around that. So they're just hard switching the output FETs to account for the lack of design here. If we probe the gate, let's probe at the MOSFET side. So that's on the gate. That's on the MOSFET gate leg. If we go before the gate, so we got where are we? Donde. So we got from the drive circuit, it looks like this, and then after the gate resistor, it looks like this. They look pretty similar. Right. It's not ideal, but it's whatever. Idle current draw of this thing is only, well, it's 1.5 amps, which is actually a little bit high. 2 amps of idle current draw for a little 3K like this, so I suspect the output FETs are cross-conducting a little bit, or there's poor optimizations in the power supply side. But we're not here to fix that. We're not here to correct systems poor designs. We're just here to do a quick fix on the output section for this one. So that's what we do. Joseph, how's it going, bro? Alright, last car amp for today. We got through quite a few. Good, right? Let me just make a quick video of this for the client to show them it working. What are the controls on the side? Where were they? The level was very high, I think. Oh no, it wasn't. It was at minimum. Oh wait, was it? No, hold on. Yeah, level was at minimum. High pass filter, low pass filter, bass, mid, and treble. I don't like that. Everything was at minimum, at minus 10 dB, which is not where you want it on these. You want it at 0 dB in the middle. So I'll just leave it at that. Or we could put mid and treble down at minimum, minus 10. I'll tell you now, it's a shame that I haven't got the air conditioning and the Proton working just yet, because I'm going to obviously be driving the Proton to get the Boomer Bust Season 2 vehicle this evening. And it did come with air conditioning, but I removed it for a second alternator, but now I've removed that, putting the air conditioning back in. Air conditioning is really good for getting rid of hay fever symptoms. Daniel, how's it going, bro? Good to see you here. Level. There we go, buddy, all sorted. So 12 volts going in, 26 hertz just on this little driver. Playing really nice. Make sure there's no turn off pop. No, it's perfect. Es perfecto. Muy bien. Está bien. Right, last one is this Edge amp that I was given here to repair as well. What's going on today? Dusty, yo, how's it going? So, just got a few things to get through in the workshop. And then a bit later on today, I'm going for a drive to pick up the test vehicle, the test cabin that we're going to be using for Boom or Bust Season 2. Very exciting times. I'm currently using a 172 amp 12 volt switch my power supply for charging a home vacuum cleaner because its charger failed and got nothing to replace it. Nice, love to see it. My soundbar has turn on, turn off pop. Any way to stop it doing that? Not really. Just it's probably a cheap one. I don't like soundbars. Anything soundbar I can get in the bin. So depends what the circuit is, but not a fan of soundbars. Me. There are ways to stop the turn on and turn off pop, but you have to get inside the circuit and make some assessments and make some modifications to the circuit, which wouldn't be super simple. You could add a relay, but obviously a soundbar is going to have multiple different channels and outputs, so you have to use multiple relays or multiple gang relays, and you have to find a supply for the relay coil that could activate the relay when it's powered up, but after the Class D is initialized. So I'm so glad you're able to figure things out for Season 2 Boom or Bust. Yeah, no, it should be good, man. Thanks. Alright, so here we have essentially the same piece of rubbish Chinese circuit that's been floating around for 20 years. It's probably got dead outputs, they always do, because the optocoupler it causes really weak drive in the output side, so yeah, there we go, dead outputs. One dead one there. It's always the one that's furthest away from the drive circuit that fails as well in these, because the drive is very weak. Type 4, yeah, type 4. They're using 640s. Yep. One, two. So just 1 and 2 on that side. Yeah, at least the output driver cards never die in these. Really simple repairs these, fortunately. Vibration damage is the cause. We have snapped MOSFET leg here from the main board, so that's our failure cause. Let's take a quick picture of that for the client so we can show them why it failed. There we go. So because it was vibration damage, that should mean the drive circuit survived. So if we cut the bad FETs out, which we've just done, we should be able to power it up and just confirm the drive circuit is okay with the remaining FETs. We also actually have, look at this on the board, we also have some copper wire strands floating around inside. Look at this. That'll give you problems as well. This is missing some power terminal screws for some reason. Where are they gone? They weren't in the box. Fortunately, I have the clip. Clip. So yeah, if we power this up, power supply looks fine, so no issues there. 9.6 volts. Yeah, let's go for like 6 amps, just because these take a little while to turn on. I do have a soft start power supply mod for these. I put in sometimes if it's worth it, but usually it's not worth it. They're just cheap piece of crap. So power up takes a while to turn on as well. These click. Okay, so there is our. Hopefully that's our positive rail over here. Yep, and this is our low side, so we should have nothing on the drain, which is good. We don't. So let's continue with the power up. See if we get Class D switching. There we go. Lovely jubbly. So drive circuit is perfectly fine. 1.1 amps idle current draw. 12 volts. Yeah, beautiful. So nice simple fix. We just need some new 640Ns, which we'll bang in real quick just now, I think, while we're here. Might as well. It's tempting to do a top board repair on this, just because it's really simple, we just need output FETs, but these don't actually take very long to get out of the heatsink, so I think we'll take it out of the heatsink. And these ones never ever have any damaged traces underneath either. So the only reason to take this one out of the heatsink would be just for convenience of soldering, and considering what we need 1, 2, 3, 4, 5, 6, 7, 8. I'm going to need 16 new FETs. It's just going to be a bit easier, I think, from the underside. Hey, nice little rail voltage short there. The rectifiers are just here. This is why I haven't unscrewed any of these ones on the output FETs yet, because the rail voltage takes about 3 minutes to dissipate in here. So, well, we just sped that up a little bit on one of the rectifiers, which is not a problem, not dangerous to the circuit or anything. All you've done is just shorted the rail cap to ground, which is fine. Oh man, there's loads of these wire strands. Like, maybe it was the vibration damage, but also maybe one of these killed the output FETs first. So many of these floating around in this amp. Right, has the rail voltage sunk down safe enough for us to do the output side? 13 volts on the positive rail and 18 on the negative. Yeah, that'll be fine. We'll use the manual one though. and prepare speed run. If I was speed running this, I would have done it top board. I use magnets to remove the bottom plates. Yeah, that's actually a great idea. I should start doing that. Also, because this had vibration damage snapped legs on some of the output MOSFETs, it would be a good idea to take it out of the case and just check the status of the rectifiers, because they might have some weakened or snapped legs as well. Although these do look alright. Alright, so rail voltage, what we got? Need a ground reference. -7, +5. That is low enough just to quickly short out with some pliers. There we go, all gone. Audio buttons, toast, yeah. Did you order the Hako desoldering thing? No, I didn't yet. I do need to though. Especially now I've worked out that I can just use a very cheap from Facebook Marketplace a voltage transformer. So I need to get a voltage transformer and I need to get the Hako. I think the cheapest place is eBay. I think they're about £175, which is a lot better than the £400 that the 240 volt version is, that's for sure. Also, having a 110 volt transformer will be very useful because it will act as an isolation transformer, so I can hook up my scope to the secondary as a ground reference for the AC side, and also it means that when I'm working on mains stuff, if it has a switch for 110 volts, then obviously that's great because that means there's less incoming voltage. So yeah, I think it would just be a good thing to have all round, really. Is the Hako one even that good? I don't know. All the reviews I've seen on the Hako one have been like very, very good. But if there's another brand that does it the same or better, then by all means, send me a link or something, and I'll check that out as well. The only one I know of is the Hako, really. I haven't done much research on them. I have tried a desoldering gun in the past, and I found that it actually just took longer time to use it because it would just get clogged up so much that you spend more time unclogging it than actually using it. So it ended up just taking longer than using the manual pump that I've got very accustomed to. Like, I've got so used to using this for years that I'm pretty quick with it. So it's got to be quicker and more convenient than just using the manual pump. There's so little thermal mass in this board. It's crazy. Bearings, I want to add a sub to my car and I can't change the head unit because modern crap. Should I go DSP or high low level converters? Sorry, excuse me. It depends really. I would probably just go high to low level converters. If the factory system sounds acceptable on the mids and highs, you don't really need to change anything about that. Then just go high to lows. Obviously, try and tap into the factory subwoofer output if you can. It might have high pass filter built in, and you'll obviously need to calibrate and control the frequencies going to your aftermarket sub. Say, for example, there is a factory fitted high pass filter that is higher than what you'd want. Then what you need to do to account for that is you need to run a very low frequency low pass filter that actually kind of touches where the high pass filter from the factory system starts. And then that will allow you to then increase the level to compensate, which will kind of get around the high pass filter being there. Does that make any sense? I could draw it on a graph. But yeah, when integrating a sub with a factory fitted system, you need really strong flexibility with your crossover, which obviously a DSP will give you, but using a DSP just for a subwoofer output is a massive waste of money. So I would not suggest a DSP for just integrating a sub to a factory fitted system. I would suggest possibly an external active crossover that has really good flexibility, but you don't need a full bloody DSP just for your sub. No. Have you got an ETA on the parts for the base face? Was it Sunday? Probably tomorrow. They'll probably arrive tomorrow. I don't know if I'm going to be streaming tomorrow though. So the base face parts stream might be Tuesday. Right. I need some 640 ends, please. Pretty simple repair this, but it's not going to be the cheapest thing in the world just because it's quite a lot of FETs. So it's time and labour. The parts cost isn't going to be very much on this. So many of these wire strands, I'm finding more. Even though I've been handling the amplifier quite a lot, there's more that just keep appearing. So before we put this back into the heatsink, I'm going to have to go over with a fine tooth comb looking for little wire strands. Thanks for the great advice. I'll go to high level. Yes. Yeah, definitely don't get a DSP unless you are honestly wanting to integrate a full active front setup or front sub integrated with the front setup that you're doing aftermarket. DSP is great for fine-tuning a fully aftermarket setup, or ripping out the all the DSP and amplification from a factory fitted system and making the most out of the factory drivers. But just for adding a sub, no, you don't need a DSP. Big waste of money. But if it has an amp, you can make the SQ so much better with a DSP in between. Not for the sub, you can't. There's not really such thing as SQ when it comes to subwoofer application, within reason. Pretty much any amp is going to sound the same with subwoofer application between 20 and 80 Hertz or 20 and 100 Hertz. So with a subwoofer, as long as you get the subwoofer waveforms in phase with the next driver up, usually it's the door speaker, but you might have some mid bass under the seat drivers, wherever the next driver up from the sub is, as long as you get the phase in line, then it's going to sound coherent. It's not super critical to get the timing exactly in line between the sub and the next driver up, because it's also slow anyway that you don't really notice. Obviously in an ideal world you will get the timing exact as well. That's fine, you can chase that if you want, but it's not super critical for getting a very listenable and great sounding coherent setup. Obviously, if you're using a DSP just for your subwoofer, then you're wasting all of that power. You don't need tons of EQing for your sub setup. You don't need channels and channels of time alignment. You don't need all these different functions and features. You just need, for your subwoofer setup to sound good, you just need decent crossover flexibility and the ability to adjust the phase. That's literally it. But yeah, for your front stage, oh yeah, if you've got an aftermarket front stage fitted, and you want to make the most of it, DSP is gonna absolutely be able to make that equipment work at its absolute best. But the DSP can't do that alone, and a lot of people don't realize this. A DSP doesn't do anything. Do you know what I mean? Do you understand? A DSP does nothing by itself. A DSP is only useful when combined with an experienced tuner. That might be yourself, but it might not be. So if you want to improve your setup in your car, if you buy a DSP and you've never tuned DSP before, and you aren't experienced with tuning, then you can actually make your setup sound a lot worse. It's a bit like trying to map a custom standalone ECU if you have absolutely zero experience mapping a custom third-party standalone ECU. You risk just blowing your engine up, just messing around with it. So a DSP is a tool, not a solution. A DSP is a tool that, in the right hands, will transform your system, and in the wrong hands, can damage your system or just make it sound worse than it was before. Actually, just looking around on the audio forums on Facebook and stuff, I feel like the DSP is kind of becoming a bit like the capacitor. You know how, like, back in the day, anyone who had even the tiniest, anyone who had a little bit of car audio experience, the answer to every solution would be, oh, you need to add a capacitor. Regardless of what was happening, clip light is coming on, it doesn't sound good, or amp keeps going to protect, blah blah blah, whatever the issue might have been, you'd always get a bunch of people in the comments, you need to add a capacitor. And honestly, from what I see on the forums and stuff, I feel like the DSP is becoming a bit like that. People are just like, oh, you need to add a DSP. No, you don't. 9 times out of 10, you don't need a DSP. Like, the majority of your average bass head or your average car audio enthusiast that just wants their system to sound a bit nicer, they're not going to benefit from a DSP, and they're not going to want to spend the money that a proper setup on the DSP costs. I think people have forgotten that head units with relatively decent flexibility and setup flexibility exist. Like the Pioneer 80PRS and the Alpine 9855R, and there are head units that exist which have 99% of the functionality that people would be using a DSP for, just with less channels perhaps. DSP 32BTRX that says DSP is the single most expensive thing I've bought for my entire system. Exactly, and I feel like a lot of people are incorrectly suggesting people buy DSPs when actually they don't need it, and the money that they would have spent on the DSP should have gone into something else which would have made their system better, a lot better, for the money. Alright, let's check gate resistors. Right, so we do have some dead gate resistors. I mean, it's supposed to be, what are these, 10 ohms? Yeah. So we've got dead one, that one is reading okay. Right, that one's dead, so number 1 on this side. These will be fine. And then we have, again, number 1 on this side is open. So we need 2 new gate resistors. Ha! Gate! How are you feeling? Yeah, I got really terrible hay fever. Bit of flux. I'm not going to bother getting out the hot air station for this. I'll just iron them on. Many lack good crossover settings for mid-ranges and tweeters, but many don't though. There are so many head units that have fantastic settings for mid-range and tweeters. The main one that I can think of, which is one that I use in both my vehicles, is the Alpine CDA 8955R. That has insane level. That has DSP levels of control for crossover, time alignment, and EQ for all 3 of the 3-way active areas: the tweeter, the high frequency, the mid range, and the low subwoofer. It's only 3-way, so it's only got 3 sets of outputs that you can control, rather than a DSP which usually has like 6 or 8, or maybe more. But for most people, having the 3 separate ways of control is more than enough, And even if someone's running a three-way active, like I am in the Proton, where you need all three of those outputs for tweeter, mid, and door woofer, you then also need the subwoofer. But you can run the subwoofer on the third one that the door speakers are running on, and all you do is you then just set a high pass filter on the amp for the door speakers and a low pass filter on the amp for the sub. So you'd ask on the head unit the third way, the bottom, the low end way, to play from like 20 to 200 hertz, for example, or a 20 to 500 hertz, or whatever the case may be. And then the door speakers obviously will play from 500 down to whatever, maybe like 120 to 500, maybe 120 to 1K. And then on the amplifier, you'd high pass them so that they don't get anything under 120. And then your subwoofer, you have a low pass on the amplifier for maybe like 60 or 80 hertz or something to blend them with a 12 dB slope or 6 dB slope if you want. And then they'll blend perfectly. And they're running on the same active channel, but you split them up with the crossovers on the amplifiers for each. Alright, that's the two gate resistors replaced as well, so we should be good to power up and go back in the case now. Alright, let's have a quick little look for those wire strands that have been everywhere in this amp, as I want to get rid of all those before it goes back in the case. Okay, I think we're good. Okay, cool. Some thermal paste on our new FETs. And might as well freshen up the thermal paste on the power supply FETs and the rectifiers as well while we're here. Doesn't really look like there's much on there, so so I did hit the solder joints with the what do you call it? This isopropyl alcohol and the wire brush. That's why they don't look shiny on the bottom anymore. I think the only ones that I didn't quite do that on yet is the gate resistors, so I should do that on the gates. But the flux that I use is not corrosive, it's no clean flux. I mean, yeah, I suppose it's still good to clean it off, but it's not going to cause any issues to the circuit if the flux is still there. So we give you a little bit of ambient sound. There we go. You can have the other microphone that's a little bit more tinny, but you get more ambient sounds of the workshop, like the Scope ASMR, for example. And you can hear the screwdriver a little bit easier, I think, in this one as well. The nice clicky motion of the screwdriver. So I haven't tested this yet after fitting these new FETs, but we did test the drive circuit with the old FETs in, so there's no reason why this won't work. But we're just kind of YOLOing it. Do you hear the scope sound when you sleep? No. It is a very distinctive background drone though, isn't it? I was thinking of uploading a 10-hour scope sound ASMR to my Bearvid's Clips channel. I thought that might be quite funny. I wonder if there'll be any people that don't watch my channel and watch my streams that actually find that nice. When you do that bass face amp, I want to purchase a spot on that amp for my name. Yeah, you're welcome to. To be fair, you've donated enough already, I'll just put your name on it anyway. What amp is this? This is an Edge piece of rubbish. It's a Class D Type 4 from Perry's Amplifier Repair Guide. If you know what that is, you'll know what this amplifier is all about. I actually reached out to Rigol, who make oscilloscopes, to see whether they'd be willing to work with me and sponsor me some new fancy oscilloscope. And actually the UK dealer for Rigol, the UK kind of company, have actually sound like they're pretty interested. So I guess we'll see where that goes, but it'd be nice to have some absolute bad boy scope, like woo! You don't really need a bad boy scope for doing audio work, but it would kind of, what would it open up? It would open up the ability to kind of really hone in on like some of the tiny nuances of these Class D designs and optimize them and stuff. Have you adjusted the BIOS on Class AB amps? Yeah, all the time. Every single Class AB that I repair where I'm changing output transistors and stuff will need rebiasing, so I do that all the time. I wonder how you find the bias parts on an SMD board. Well, you're just going to have to know the circuit. If it doesn't have potentiometers for adjusting the BIOS, then you're just going to have to use your initiative to reverse engineer the circuit if you don't have a schematic, to kind of look at everything, look at where all of the parts go and where the biasing parts, the resistors are that you need to change. Bander hides the crossover switch. It's not hidden as such, but yeah, it's on the PCB underneath the back. Like it is documented in the manuals. It's not like they're hiding it, but yes, it is not super obvious on the side of the amp where the crossover switches are on those. Just get a used Agilent branded Infinium scope. I like the way you say just get. Dude, those things are still mega money. The beauty of working with Rigol is that they would be sending me this for free. I'm like, if getting a new scope requires me to spend thousands of pounds, then it's not happening. I'm perfectly fine with my trusty old HP Agilent, what is this, 54602B. Beautiful thing, love it. Awesome little scope. Yeah, I thought maybe we could grab something crazy and modern with, I'd love something I can plug in via the PC, via USB, so I can give you like a proper light, a proper feed, a proper captured feed of the scope. And also I'd love to have something with data logging so that I can, you know, if amps that have intermittent faults or weird problems that only present themselves after they've heated up and stuff like that, I can connect up a bunch of probes and just walk away, work on something else, and then check the log for issues. I also want a colour screen. My scope is a O1. I did try an O1 handheld scope and I absolutely hated it, so I kind of like didn't ever really consider O1. It has VGA output, oh, that's cool. Also battery powered, nice. So obviously I don't need the battery powered side, but the VGA output is nice, it means I could capture it with a capture card. Alright, let's power this up and just confirm that it does still in fact work. My Rigol is so slow. I see, I'd hate that. I need something to be absolutely mega responsive. So just sanity check, confirm there's no shorts. Looking good. Oh no! What? Okay? Oh, you're joking. What? What? That suggests that there's a solder bridge. But where? I went through all of those on the underside of the board. That might mean I've got to take the board out again. This is why I should test it before I put it back in the heatsink, but I was like, nah, it's fine, fucking Alright, we may be able to sort this without taking the board out of the heatsink again. The problem is we don't know which FET it's on. We don't know which one, because it's between drain and source, and they're all fucking in parallel, aren't they? Ah, that is heartbreaking. Yeah, that is proper, fully heartbreaking. That is. Yeah, we'll do something. Yeah, okay. Let's do something clever with the power supply. So let's connect up. What is it? So yeah, we need something on. We need something on the drain here, and we need something on the source. It's going to be there. And then we need to set the multimeter to volts, millivolts probably. Then we've just got to turn the power supply on with low current. Okay, so there's 4 amps there. Alright. So between this one and this one we have 0.06, 0.06, 0.06, 0.06, 0.06, 0.05, okay. go down to 200, discard down to millivolts. 0.56, 0.64, so it might be that one, third one. 0.8 and 12.4. Nine 9.1, 10.6, 5.6. I think it's this third one in. I think it might be this third one in. So what I'm planning to do is to remove the FET and then do lots of sucking through the holes, which should hopefully pull through the solder with the solder bridge on it. And I can just refit that FET. Alright, let's check now. I wonder whether I got the right one or not. Nah, it's still there. Yeah, no, it's gonna. I think it's gonna have to come out, but we're not doing that just now. We're doing that some other day. Fuck that, can't be bothered. Not doing that, not taking that out again. Guys, it's been a pleasure. Thanks for jumping with me this stream. 2 hours 25, not too bad. Got through quite a few bits today. This is repaired. Just got to find the solder bridges I made by mistake. Oh, actually, in fact, it could actually be on the other side. Oh, wait, no, it wouldn't be on the other side, because that's high side. You know, it is on this side. Really frustrating, but I should have checked it before I put it back in the heatsink. That's just me being poorly and just wanting to get this done as quick as possible. But there we go. This evening I'm going to drive to pick up the test cabin for Boom or Bust Season 2. I may or may not go live. If I'm still feeling pretty awful like I am now, I don't want any extra distractions while I'm driving, so I don't know whether I will go live, but if I do, then I guess you'll see me then. But yeah, have a great rest of the day, enjoy the rest of your weekend, and I'll see you next week. Peace out, see you later, bye bye bye.